Now I hope you did go and play with that exercise, either on a graphics calculator or on GeoGebra or some other dynamic geometry package. If you didn't, go do it now. I'll wait. Ah, you're back. Good. So the first circle theorem about angles says this. The angle at the centre of a circle is twice the angle at the circumference, provided it's subtended by the same arc. What is that saying? The angle at the centre is double the angle at the circumference, subtended by the same arc. For example, if this angle is 70, this is 140, and vice versa. And it doesn't matter if one's on the outside or the inside. If this is 105, then this one is a reflex angle at 210. It's still double this one. And it doesn't matter if it crosses over the side, it's still the same. The angle at the centre, subtended by the same arc, is double the angle at the circumference. The second theorem is a consequence of the first. The fancy word for that is it's a corollary. If you can prove the first theorem, then the second one is a very simple special case, a very simple consequence. If I have a semicircle for my arc, then the angle in the semicircle, the angle at the circumference of the semicircle, is 90 degrees. And although the book's kind of a bit misleading here, it doesn't have to be there. This point could be anywhere on that semicircle, just like you tried, I hope you tried, using dynamic geometry. It can be anywhere in that semicircle and you will have 90 degrees here. Why? Because the angle at the centre is 180 and it's double this. Let's try some examples. Here I have an angle at the circumference subtended by the same arc as an angle at the centre. So this one must be half the angle at the centre. It's half of 126, which is 63. Here, I have an angle in a semicircle. So this one is 90 degrees. If this is 90 and that's 70, this one has to be 20. It's the number of degrees left to get to 180. Let's try another example. Find the size of ACB. How big is this angle? Well, if this is 25, this must be an isosceles triangle because that's a radius and that's a radius. So this angle and this angle are the same. That's 25 degrees. Well, if they're both 25, how big is the angle in the centre? Well, it's 180 minus two angles of 25. 180 minus 50 is 130. And if the angle in the centre is 130, then the angle at the circumference, subtended by the same arc, must be half of 130. So that's 65 degrees.